Okay, so we just looked at the uh, substitution method. So now we're going to be looking at the elimination method, which is the other method that's possible. Now, if you like using one of these methods, you can stick with it. But there's going to be some cases where the elimination method will be easier to go through than the substitution method. Okay, and there's going to be times when the substitution method will be easier. But if you come up with a problem and you go, I'm more comfortable using the substitution, then do the substitution method. But I'm going to teach you the second method, the elimination method, which most people say is a little bit more difficult to do. But at times it is easier to do the elimination method than the substitution, because the elimination method you'll avoid fractions, unlike the substitution method, which you'll run into some fractions here and there. Okay. All right. So elimination method. So what the elimination method basically is, you're trying to eliminate something. You're trying to eliminate one of the variables. And what you're doing is that you're going to take them and you're going to stack the two equations on top of each other so that all the variables match up and down. And then when you add it, you want one of them to disappear. Well, if you see here, when we add this, x plus x is 2x. That doesn't disappear. Y plus 2y is 3y. That doesn't disappear. So what we have to do is that we have to multiply either the top or the bottom one by a number. And so I'm going to multiply the top one by a -1. Now when I multiply it by a -1, I distribute this -1 to each part, giving me a -x minus y is equal to a -6. And then underneath that I have x plus 2y is equal to 10. Now, if I add them up and down, -x plus x is 0, so the x is gone. -y plus 2y is y. -6 plus 10 is 4. And as you see, I have y equals 4. And that is one of our points. And now what I'll do is that I'll take this 4 and I'll plug it in for the y and solve for x. X plus 4 is equal to 6, which means x must be 2 because I subtracted 4. And so now my point is 2, 4. And as you see, the elimination method came up with a nice round number. Now you could have used substitution method for this one, which would have worked too. But the elimination method is nice, just something different, and sometimes it is easier to do the elimination method. All right. Alright, so now let's say we run into this, which is a little bit more difficult. Okay, it's not as easy. It's not as straightforward, I should say. And as you see here, there's not a single number I can multiply either the top or bottom by to eliminate either the x's or the y's. And so what I'll do is I'll multiply both, the top and the bottom, the first one and the second one, by a number. I'm going to multiply the top one by 3 and the bottom one by 2. Now when I distribute it, I get 15x minus 6y is equal to -57. And then the second one, I get 4x plus 6y is equal to 0. Add those up and down, I get 19x is equal to -57 because the y's cancel. -6 plus 6y is 0. Solve for x and I get -3. Now I got a -3. I'm going to take this -3 and I'm going to plug it in for, let's say, that one. So I've got 2 times -3 plus 3y is equal to 0. Oh, 0. So I've got -6 plus 3y is equal to 0, which gets me 3y is equal to 6, which means y is equal to 2. And so my answer would be 2, -3. Okay. And then if I were to take these and plug it into the first one, I would see that it also works out. 10 minus a negative. Oh, wrong way. This should be -3, 2. As you see, it would be -15 minus 4 is -9. Okay. Yep, that was my mistake. The x was -3, the y was 2. Okay. And there's more of the work. All right, so now let's look at these. So the first one, I'm going to multiply the second one by 3. Okay, that gets me, I'm rewriting the first one. And now the second one will get me negative 9x plus 3y is equal to negative 3. Adding up and down, I get 0x plus 0y is equal to 0. Well, does 0 equal 0? Yes. And if you ever get this case where you get 0 equals 0, then all you have to do is rewrite one of these equations. Negative 3x plus y is equal to negative 1. That is your answer. Because it's every point on that line would work. So if you pick any x and y that agrees with one of the statement, it's going to work with the second one because these are dependent. Now let's look at the next one. I'm going to multiply the top one by negative 3, which will get me a negative 6x plus 9y is equal to a negative 18. And then we've got 6x minus 9y is equal to 9. Add up and down gets me a 0x plus 0y is equal to negative 9. Well, does 0 equal negative 9? No. And if that's the case, you will have a no solution. Or another way of saying it, these are parallel. They will never cross. That's what this is saying. So if you ever get something that they don't equal, 0 does not equal 9, or negative 9, that is a no solution. Okay? There is no answer. It's a no solution. If they do equal 0 equals 0, then it's all solutions along that line. And so all you'd have to do is rewrite one of those answers. Okay? And that's the elimination method. And so what I'd like you to do is I'd like you to do the elimination method on these two. Okay, they're fairly simple. So again, remember, one of the functions you're going to multiply by a number, and then you add the top and the bottom. So add them down and see what you get. Solve for one of the variables, plug it in. Once you have that variable, plug it into the original, one of the original two, and solve for the other one. And you should get a point. Okay? All right? And that is your elimination method.